Okay, I'm going to keep going as fast as I can. If I get to something that's tough, I might have to skip over it in the interest of time. This is a polynomial that is a cubic polynomial. So it is third degree, so degree is 3. Find f of -1. -1 to the third power is -1 minus 4 times 1 when you square it, minus 5 times -1. So just be careful with your minus signs. This is -1 minus 4 plus 5. That equals 0. So that is a 0. Find all of the zeros. Well, to do that, you're going to factor this, and that's going to give you, when you take out an x, it'll give you the quadratic, x squared minus 4x minus 5, which you can then factor into two binomials. Don't forget that x there, because that's one of our zeros. And I get x and I get x. Two numbers that multiply to make -5 that add up to make -4 would be -5 and +1. Each of these will produce a 0 when I set each of these equal to 0. So this is when x equals 0, this is when x equals 5, and this when x equals -1, as we discovered before. So there are the zeros. That's part C. Sketch a graph without calculators. If I put my axes down and I go to my zeros first, there's 0, there's 1, 2, 3, 4, there's 5, and there's -1. You should put a scale on here at some point. I guess I'll put it down there. And -5. And then you know that it's the lead coefficient is 1, or is positive at least, so it's going to go up on the right from this 0. It's going to go down on the left from this 0. Passes through the origin, so something along these lines is fine. You could pick a number in here like 2 or 3 and plug that in. If it's 3, that's 27. 9 times 3 is 36. That's a negative, what did I say? -30. So it's -9 minus then 15 more. So that might need to be scaled. So that's like -30 there. Okay, and this is like +30. But that's not a huge deal. It's more getting the general shape and the zeros that's important. Okay, radicals with these, you're just breaking this down into 5 and 25, and then 5 and 5. Always break it down into prime factors and look for that hockey stick. When it's a third root, you're looking for 3 identical numbers. There, we found it. There's no other x's, so I can't do anything with that, but there are 4 y's, and I need to take out only 3 of them. 1 is left behind because I'm taking out perfect cubes. Z to the 6th, there are 2 groups of 3 z's that I can take out. So then this becomes 5 on the outside, no x, but y on the outside, and 2 z's come out and are multiplied. And then I've got the third root. There's my x, there's my 1y, and all of the z's came out. So that's the answer for that one. Same type of thing with this one. 18 is 2 times 9, which is 3 times 3. I'm sneaking it in there. So I get a little hockey stick. Out comes the 3. I've got 3 x's, but I'm only taking out 2 of them. So a pair, when I square root them, comes out as an x. How many pairs do I have when there are 7 of them? I have 3 pairs. So out come the square roots of the y squareds, and there's 3 of those. And then left behind is my 2, and then that one y. So that's the answer for that. I'm always going off the screen on this, I think, so I've been doing that whole thing with no screen. I'm so sorry. Got to pay attention to that. But anyway, what I did was I broke down the 25 into these prime factors of 5. I take out the cube root of 5 times 5 times 5, and that's 5. Again, I break this down, I pull it out, just like you heard me talk when I was off screen. Alright, I'll stay on screen here for this. F of 3, that's pretty straightforward. It's just going to be equal to 5 minus 2 times 3 all over 3. So 5 minus 6 is -1 over 3 is -1/3. Find x when f of x is going to be equal to -4. So I just put -4 and I write my equation as it began, and now I'm just going to put it over 1 and cross multiply. So I get 5 minus 2x equals -4x. I add 4x to both sides. I get 5 plus 2x equals 0. So I'm going to subtract 5 and then divide by 2, -5 over 2. Alright, so the trick is just set this equal to what f of x is and then cross multiply and solve. The domain for this is any x value, so the domain is x is all real numbers except that x cannot be equal to 0. The range then coming out, you're going to have to look at the graph, but I think, yeah, that is going to give you all real numbers, maybe except it can't be -2. But look on the calculator for that one. F of x, I'm guessing, is all real numbers, except f of x is never, ever, ever going to be equal to -2. That's your horizontal asymptote, and it will never be equal to that value. Alright, the asymptotes, there we go. Vertical asymptotes at x equals 0, horizontal at f of x equals -2. How do I know that? I know that because I can say as x goes to infinity, this 5 becomes irrelevant, and I've got -2x over x. The x's cancel out and I get -2. That's the horizontal asymptote. Alright. Similar type of reasoning for these guys, domain, range, and asymptote. I changed this from Mr. Young's original to make it a little bit easier. Again, you have to look when you can get division by 0, and the answer is you never will, because no matter what I plug in for x, I'm squaring it. Any negative becomes positive. There's no way I'll get 0. So the domain is simple. X is any real number. The range coming out, I'm going to have to look at the graph of that. That's where you can use your calculator and see if there are any gaps, see if there are any boundaries. I'll fill it in on the posted online answer. Asymptotes, none, no asymptotes. Here we go though. There is going to be an asymptote here, and it will affect the domain. It's when x is -4. So the domain, x is an element of all the reals again, but x cannot be equal to -4. So this is a vertical asymptote. The range then is going to be that f of x can be any real number, but you're never going to get this equal to 0, because no matter how big this is, that number in the numerator, x, can never be equal to 0. But again, look on the calculator. Horizontal asymptote is 0. Okay. Given this rational function, find x when f of x equals 1. So you just set this equal to 1, and then cross multiply. I'm just going to skip to that. X squared plus 5 equals 3x squared plus 5x minus 2. And then I'm going to subtract x squared and add 5, so I get 0 equals 2x squared plus 5x, and when I add 5 I get plus 3. Okay, and we're going to try to find x, so we want to see if we can factor this. The only way to get 2x squared is 2x and x. The only way to get 3 is 3 and 1, or 3 and 1 this way. The rainbow check is going to give you, if this is a plus, then that's going to be, these are both the same sign, they're both pluses. So yeah, so plus 1 I think it is, and plus 3. So check, that's 1x, and whoops, 6x, that doesn't work. So if I do plus 3 here, and plus 1 there, then I get 3 and 2 does give me 5. So I'm going to write that again, 2x plus 3 times x plus 1. Okay, so my solutions are x equals -1 and -3/2. Find the sum of the measures of the interior angles A. So if I make like a little chart here, if this is interior angles and this is exterior angles for the polygons with 5 sides, the interior angles, well, the simple idea is that if you've got 5 sides, you can draw 2 diagonals from one vertex. This is a triangle, that's triangle 1. This is another triangle, that's triangle 2. This is triangle 3. Each of these triangles has a total of 180 degrees, and you can add them all up, and that's 540 degrees. Okay, with 12 sides, you're going to get 10 triangles. 10 times each triangle being 180 is 1,800 degrees. And the formula is you're just going to multiply your number of triangles is always going to be the number of sides you've got minus 2 times 180. Exterior angles are always 360. Okay, what a wonderful formula that is. They never change the sum of those exterior angles. How many sides does a polygon have if the sum of its interior angles is 2,700? So 2,700 is equal to this formula, 180 times n minus 2. You just solve that. You can cancel a 0. You can divide 270 by 18, and then you can add 2 to it.